Hi, my name is William Horton, and this is what you can do with init.py, but probably shouldn't. I'll start with a note on the pronunciation of the file name. Technically, it should be Dunder Init Dot Pie, but hearing me say Dunder, Dunder, Dunder throughout this talk would probably get old. And also, there's very few lessons that I'm going to give you in this talk where I'll say, absolutely do not do this, but I'm very comfortable saying, never actually name a file init.py and put it next to Dunder Init Dot Pie. That is just going to set you up for confusion. I would really not suggest doing that. And so when we talk about init.py, I think we can understand that it's the one with the underscores. So if you have any level of experience with Python from beginner to many years in, you might have had this question: what is init.py doing? Why is it in all of these directories? I found myself asking the same question, and before I started researching this talk, my answer was probably something to do with modules. So like any professional developer, I consulted Stack Overflow for help with my question. What is init.py for? And I was lucky enough that there was already an answer that had been viewed 1.3 million times. So I was in good company. And on this page, I found what I needed, a link to the relevant Python documentation. Before we get too far in, I wanted to give an outline of what exactly are we doing here, or what's in it for me. Okay, I promise that's the last time I'll make that kind of pun in this talk, but I had to do it at least once. So what we're going to be doing first is to outline the common uses of init.py. What is it intended for? How is it used commonly in different libraries? Then we'll get to what I would call interesting uses, things that you might not see everywhere, places where people have really stretched the use of this file in ways that are illustrative of how you can use it. And finally, we're going to consult big data. So back to where we were, a link to the relevant Python documentation. And what does that tell us? So Python's import system. Python defines two different kinds of packages: regular packages and namespace packages. This leads to the question, what exactly is a package? And the definition of package is somewhat recursive. So a package is basically a Python module that can then contain submodules or subpackages. And on a technical level, it's basically the same as a module, but with this special attribute called Dunder path that we'll get to later. And this leads to the question, what is a module? And a module has a namespace that can refer to other Python objects. And modules are what are loaded when you import. And to illustrate this with an actual example, if you had this statement from foo.bar.baz import great function, foo in this case would be the package. You can access into that package using this dot notation to access a sub package, and then another dot leads you to a submodule where you can get your function. So we saw from the documentation there are two different kinds of packages: namespace packages and regular packages. We'll cover namespace packages very briefly to start, because they really don't have anything to do with init.py. Except they do lead us to one use case. What can you do with init.py? Which is delete it. See, the PEP that outlined namespace packages, PEP 420, actually made init.py optional. So there's no longer going to be any warning for directories that are missing it, and you actually can import from them. And it'll create what's called a namespace package. Or as one very excited Reddit user put, instead of all that stuff where every folder has to have init.py, you can do from any effing folder import awesome. So clearly some people were excited about this idea that init.py became optional with the advent of namespace packages. And so this illustrates how this would work. So I can define a package with a module and put Python code in it. And you see there's no init.py, And it still works. I can still import from this just as if I was using a regular package with init.py. So for a technical level, it is optional to include these init.py's. You can delete them, but you probably shouldn't. And in PEP 420, they actually give some reasons. So they say it's not actually getting rid of regular packages. And actually, there's performance advantages of having a regular package with an init.py. So there's still some good reasons to actually include it. Or as a Stack Overflow user put it, do not use namespace package. It's for very rare use cases. And unless you actually know that you need this namespace package, you should probably stick with regular package, which is what's suggested by the naming. Regular packages are for regular use cases, and namespace packages are for some special use cases that Python wanted to support. So I would say, for the most part, stick to regular packages. So let's get into regular packages. Basically, a regular package is the way that Python packages existed up until Python 3.3. So 3.2 and earlier only had regular packages. You define an init.py file in a directory. And when you try to import from that directory, the code in that init.py file will be executed. And any of the objects there become part of that package. So the reference to the history, or kind of pre 3.3, brings up the question, why init.py? Why did this even exist in the first place? So if you look at some of the older documentation, so this is the Python 2.7 documentation, basically what they were trying to avoid is overshadowing existing packages by having your directory names kind of overlap. So this is an example, string. So if you had any directory in your project named string, it might actually shadow the built-in string, and you probably wouldn't want that. So by default, unless you put an init.py in it, they would consider that you didn't actually want to look at that package or look at that directory as a package. So this is the use case, and this is how it existed up until the introduction of namespace packages, and kind of why they introduced init.py in the first place. So this is an example of how you might use init.py. So you can see I have a package. Inside the package, I have init.py, and you can define any kind of Python object within it. So you have a class, a variable, a function, any of these things. And then when I import from my package, I can access any of these objects that exist in that init.py file. So what are some common uses of init.py? First of all, we might have package metadata. So it's very common to include version, author, and other information. Some of them might be more extensive. You can see this is from the kombu package, which is from the Celery project. Some just stick to a Dunder version, but I would say it's fairly common to find at very least the version defined in the init.py to give someone an easy way to check when you import the package to see what version do I actually have. A second use case that I would say is pretty common is making your API flatter. So what does this look like? So let's say I have this music maker library, and I'm putting some classes in there. So I have an instrument class, which is kind of a base class. I have guitar and violin. And people who are using my music maker package can import guitar and violin because I've defined them in the init.py file. But let's say that I want to expand my project, and let's say guitar is going to have a bunch of code to itself, and violin might be part of other strings that I want to organize into a different file. So this would be great. This is probably the kind of refactoring that you want to do at some point. But it does bring up a problem of how do I expose the API of my library? Maybe I really like to still be able to expose guitar and violin on the top level under the Music Maker package. So basically, if I import from these other files into my init.py, that would expose it on my top level package and allow me to move the code around without actually changing the API to the user. So they would still be able to do from Music Maker import guitar and violin. I would say this is a very, very common use of init.py to make kind of a flatter API so that they don't have to actually be aware necessarily of how you've organized all the files in your project in order to access the main classes and functions that you want to expose. Another interesting case that I found in a couple of init.pys I looked at least is enforcing dependencies. And so with the end of life of Python 2, this starts to be a way that projects enforce this. And you can imagine that there's ways to set this on the metadata and other ways to specify basically only use this with Python 3. But the best, or I guess the most foolproof check you can have is in init.py. So you know it's going to execute as soon as it gets imported. So there you can check the version info and basically raise an exception and say, I'm not going to let anybody import this if they're not running Python 3. And in pandas, we can actually see a more kind of sophisticated use of this dependency checking where they can say, okay, we're going to define certain dependencies that should exist. And within init.py, we're actually going to try to import them. And if we can't import those dependencies, we're going to raise an error. And so this is a way to enforce these dependencies basically at import time, so you don't run into any problems where your code later is trying to use these things and the errors might be less harder to grasp. So it can be nice for the user to have a clear error message coming just from the import level. So that could be for any kind of dependencies you might want to define. So those are some of the common or more, I guess, useful cases where putting some code in your init.py might get you some benefit for the project. Now I wanted to move into more interesting examples. One of these is suggested by the documentation. So the init.py can set or alter the Dunder path attribute, which I mentioned earlier. And this is how basically people did namespace packages before PEP 420, sorry. So what does this look like exactly, and how could we use it even after namespace packages already exist? So within init.py, you're able to modify this attribute, Dunder path. And so let's say I have two directories. I have one directory, and then I have what I've called directory 2. And let's say that from the first directory, I actually want to be able to import modules that exist in the second one. That actually is totally possible using some weird logic in your init.py. So you can see I've done an append on the path, and I've added the path to my second directory to the Dunder path attribute. And this would actually allow me to do from directory.foo import foo. So importing a class that I defined in the other directory. Now, this is kind of strange. I would say that some of the uses for this could be, somewhat, beneficial, and some of them might be a little bit more devious. So this could really, I would say, mess with people who are trying to understand your code or look at it. I wouldn't necessarily suggest doing this, but in case you run into maybe some code that was implemented before namespace packages exist, or if one of your coworkers gets very creative, this will help you kind of understand, okay, what is Dunder path really doing? Why would we want to modify it? So this is one of the, I guess, trickier, weirder things that you could do with init.py. Another more interesting thing I came across, this is within Kombu, which is a Celery project. So you see, let's go through these lines. We have static a hack equals true. The second line, if you really parse it, is basically taking that same variable and setting it to false on the global level. So you've set it to true, and then you actually set it to false, and then you check if it is true, you're going to import these things into init.py. So that would be kind of the API flattening case we talked about. But in a kind of weirder way. So if you read the comment, basically they don't actually want to execute this code, but for static analyzers, they want to be able to have these seen as if they were imported so that all the kind of type checking can work. And why would that be? If we dig into this a little bit more, we can see that they're actually doing something even more interesting in their init.py, which is they're importing a kind of lazy loading system. So when you do kombu dot something, it's not actually already there in the code, which is how kind of we saw before is when you import, it should execute init.py, and it should have all of the other code kind of loaded into it, bound on that namespace. So they kind of point at this other file and say, okay, we can look at the rationale. And basically, for purposes of exposing this API, this other project, WorkSug, wanted to expose a lot of things on the top level. So WorkSug dot whatever. But that would mean loading a ton of code. This is a fairly large project. And so they implemented this workaround kind of in the Python module system where they lazy load each module as its access. So when you do WorkSug dot something, it's only then actually going and loading that part of the module, which is kind of interesting and definitely could have its use cases. So we come back here. If you were to look at the rest of this file, if you are interested in this kind of thing, you can see they've actually defined some very interesting code dealing with the module system to say, okay, we don't want this to work like kind of a regular init.py where it would execute it and load all the stuff. We're going to say it's actually, going to do this lazy loading thing. So this is kind of cool, and maybe you might have a use case for this. So those are a couple of the interesting use cases, but finally we're going to look at big data. And what do I mean by this? Luckily, there's a ton of GitHub data available publicly on Google BigQuery. This is a project that was announced in 2016 where they collected from over 2.8 million GitHub repositories and stored it and made that data available. So this can help us answer some really cool questions if we're able to formulate the queries right. And so we're mainly going to be looking at two of these tables that are exposed. Basically, there's files, and there's also the contents of the files. And we can join these together, and this gives us basically what repo is the file in, the path to the file, the size of the file. And if we filter down to only paths with init.py, we can start to see some interesting things. We can answer questions like, what percent of init.py files are just blank? And if this were a live talk, I'd probably do a show of hands, but I'll let you do this at home. How many people think that greater than 50% of all init.py files in these 2.8 million repos were just blank files? And how many people think that it was less than 50%? So it was actually pretty close. But 46.67% of all the init.py files that I could query for in this data set were just size equals 0, nothing in the file. So, despite all the things I'm telling you about init.py, I would say it's definitely always an option to just leave it blank. Another question would be, what is the most init.py files in a single repo? And the answer was 3,886. And so I had to look at this repo. And it's this repo called Lambda Packs, which is kind of interesting. And it's basically packages of different libraries for use in AWS Lambda. So that kind of explains why there's all these init.py files. This is actually a repo that has a ton of different libraries within it. But there's also repos that have a ton of init.py files, not kind of counting vendor dependencies. So the Azure SDK for Python, as far as I could tell, didn't have kind of these dependencies in it, but just is a really big library, and it has almost 2,000 init.py files. And finally, a very interesting one to me was, what is the largest init.py file that GitHub has ever recorded? And so this library called Semba in Semba init dot py. So I dug into this. I went to GitHub. I'm like, I want to see what the biggest init.py file is. I've been doing this research on init.py. I've got to know. And this file was so big that you couldn't even see, it couldn't even be rendered in GitHub using the Python renderer. You had to view only the raw file. And this is over 2.5 megabytes worth of data in this file. And so you can go into it in the raw version and see it is a lot of data and defining some constants, and it has something to do with science. But the really interesting thing to me was to see this actually had to do with a PhD project, and seems to contain a ton of the code related to this project. So that's a really, I think, a great answer. What can you do with init.py? You could write a whole PhD in it if you really wanted to. You might end up, again, with maybe 2.5 megabytes worth of code in this file, but I think that's a pretty cool use case. So that's kind of one lesser known project. I don't think it's very widely used. So what can the data tell us about the projects that you know and love? And thankfully, the public data included this table, sample repos, which basically narrowed it down to only repos that had gotten at least 2 stars during this time period when they were collecting the data. And so if I join onto sample repos, and so I only use files from there, this starts to identify some maybe more common projects that have these large init.py files that we can dig into. So one that showed up is Faker, a very popular library for fake data, which I've used myself for tests and other things. Over 10,000 stars. And it had this huge init.py file. This is over 4,000 lines of code. In this file, over 170 kilobytes. And so I was very curious digging into this. And basically, you can see if you look at the file name, this is the provider for the Bosnian language for a list of jobs. And compared to the English version, it's a lot bigger. It's like almost maybe 6 or 7 times bigger. And in the file comment itself, it says this data came from an official government list of professions. And so I was digging into this, and I said, okay, I want to see this list. Sadly, this site, referenced in the comment, can't actually be accessed anymore. So that leads to another answer for what can you do with init.py. You can actually store government data in init.py. So this is a repository for the Bosnian language job information. Another project that showed up in this query was Airflow, an ETL tool that I've set up in my company. And they had at least one init.py file that was also topping 170 kilobytes. So I went to the repo, dug into it. But I was a little confused because when I got to models/init.py, it was only 37 lines. So where did all the code go? Where did it go out of init.py? So I did a little more digging into the history on GitHub, and I found this PR, move models out of models.py. And the description says, finally moves all the classes out of the infamous models.py. And one clarification there, because this also confused me, is there's no models.py file, and you can see that in the diff. So basically, it was removing over 4,000 lines of code from models/init.py. And in total, this PR touched over 8,000 lines of code. So I would say one thing you can do in init.py is move potentially a lot of code out of it. So this is something to keep in mind as your project develops, is what should go in, what should go in other files. So maybe you don't necessarily end up having to have a contributor clean this up a couple years down the road. But on the other hand, you can get pretty far with this. And this obviously worked for Airflow for a long time. So this is one example of a very large init.py file that did a lot of heavy lifting for a big project. So I gave you an overview of some of the more common and more interesting things that you can do with init.py. If you have any interesting examples of your own, I would love to hear about them. You can tweet at me at Horton Here's a Foo. Thank you.